Hello everyone. Today we are going to discuss the design of a parking lot. This is going to be a low level design question and you can be asked this question in one of two ways in your interview. Either it can be a face-to-face pen and paper discussion round which will be of 60 minutes, actually 45 to 60 minutes, or this can be a machine coding round of 75 to 90 minutes where we'll have to write code in an editor. So what we are going to do will be a machine coding round and we will write the code and we will see that it passes all the test cases in a multi-threaded environment, and we will be using CodeZym as our editor or the ideal platform for running all the test cases. So let's start. Let's go to CodeZym.com and the first question itself is design a parking lot. So let's open it and go through the question. So basically our parking lot will have got two kind of parking spaces, type 1 for two-wheeler vehicles and type 4 for four-wheeler vehicles. There are going to be multiple floors in the parking lot, and on each floor the vehicles will be arranged in rows and columns. Some of the parking spots will be inactive, so we cannot park there. And not to forget that our code will be tested in a multi-threaded environment, so we need to use thread-safe data structures. Now the init method here that we need to implement gives us basically this parking string parking three-dimensional array gives us the blueprint that how our parking lot will look like. So basically parking ijk means it's a spot on ith floor, jth row and kth column, 0 based index, and its element will be of four types. If it can be 4-1, which will indicate that this parking spot, if parking ijk is 4-1, then it's a four-wheeler parking spot. If it's 2-1, then it's an active two-wheeler parking spot. And if it ends with 0, that is 40 and 20, then it's an inactive parking spot and you cannot park here. Let's see the example. So basically we have here a parking spot, parking lot, which has got one floor and 4 rows and 4 columns on each floor. So this is a active four-wheeler parking spot. This is a inactive two-wheeler parking spot. This is an active two-wheeler parking spot. Another inactive four-wheeler parking spot, and active four-wheeler parking spot and active two-wheeler parking spot. So total we can count, we have got 7 active two-wheeler vehicles and 6 active four-wheeler vehicles can be parked here theoretically. Now let's just go through the methods. The core feature will be the park method, where you will be given a vehicle type and vehicle number and a unique ticket ID, and you need to park the vehicle. So, and another core feature is the unparked vehicle or remove vehicle, where will you be given either the spot ID or the vehicle number or the ticket ID, which was assigned when the vehicle was parked, and you need to remove it or return an error 404 in case of any error like vehicle not found or it has already been unparked. The third method is search vehicle, where you will be given either spot ID or vehicle number or ticket ID. This method is useful in case someone does not have all the details, it has got only one of the details, so it's easier to search. The fourth method is int get free spots count. So this method is useful because we need to display the number of free spots in front of each floor on the display boards. That's why this method is required. Now let's go for the solution. For solving any low level design problem, you have to actually figure out two things. The first one is data that is getting updated by multiple threads. We also call it shared mutable state. And the second one is how will we arrange that data in different classes. So here all our design patterns or the thread safe data structures or the basically the synchronization and lock-in come. So let's take the example of our parking lot class and see where our data is getting changed. The first place will be parking spots. So whenever we park, then we are basically assigning a vehicle, that is its vehicle number and ticket ID, to a parking spot. And whenever we are unparking or removing vehicle, then we are basically removing those details from a parking spots. So this is the first data structure or class that will be hit by multiple threads. because park and unpark methods, all the methods of the solution class will be called by multiple threads. The second will be parking floors. So each parking floor will keep a collection of parking spots, basically in two-dimensional rows and columns. So this is the second data structure which will be held by multiple threads. And the third is search manager. Since we have to index each vehicle when it is parked, so that we can search it using its spot ID or using its vehicle ID or its ticket vehicle number or ticket ID. So we need a search manager to index the data, and that part will also be getting updated by multiple threads. So a basic class diagram for our parking lot problem will be, there will be a parking lot or there will be a class solution, and the parking lot or class solution will have a collection of parking floors, and each parking floor will have a collection of parking spots, and the data structure inside these two parking floor and parking spot classes will be held by multiple threads. Now it may be difficult for you when you are beginning to figure out these two steps, which data is getting updated or how to arrange that data. But as you practice more and more low level design questions, then you will be able to pick up patterns and things will become easier for you. Let's start working on the solution. I have a folder on my laptop. Let's copy its path. Let's go to IntelliJ and open, paste it here, and open in this window itself. Now we are here. One more thing which we need to do is go to the bottom of it and use an option mark directory as and mark it as sources root. So we will get Java autocomplete in this. Next, let's do a Java class here, class solution. It's done. Now let's go to the our ID, online ID, and copy all the code from this parking lot class here. And I named our class solution because all the classes in CodeZym are named solution. Now there are compiler errors. To remove those compiler errors, what we have to do is come back to the bottom and just remove this, uncomment this. We will comment them back when we paste them back to the editor, and all our compiler errors are resolved now. Now just look at this parking result class here. This class will be result from the park method as well as from the search method. So it's basically a status, HTTP status, and a spot ID, vehicle number, and ticket ID. And for now, this is all. Based on the discussion till now, it is clear that we need three classes: the parking spot and the parking floor and the search manager. So what we will do is we will go through all the fields and not look at the exact methods, just their signature, and we'll look at the method codes later. So parking spot has got a spot ID and vehicle type, which are not going to change after initialization, and it has also got a vehicle number and ticket ID, which will change every time vehicle is parked, that is assigned to this parking spot, and when it is removed. So these are the four fields that we need to remember: spot ID, vehicle type, vehicle number, and ticket ID. Then we go to the parking floor. So do not worry about this data structure for now. We'll look at them later. So what we need to know, what does parking floor takes care of. So for now, parking floor will have a constructor which initializes it using the parking spot and the list of vehicle types or set of vehicle types. The next, parking floor will have the park method, and it will also have the remove vehicle method for only that floor, both methods, and also it will have a free spots count. Since it's taking care of the parking and removing a vehicle, so it's the actual good place to keep the list of free spots count as well. So do not worry about the implementation of these methods. Just for now, just remember that parking floor class has got park, unpark, or remove vehicle, and the free spots count method. Next is the search manager method. So search manager has got similarly index method and the search vehicle method. So we will not worry about the implementation for now. Just remember that there is an index method and search vehicle method. So what we are going to do is we are going to use these methods of these classes in the solution class. We'll go through the code in our solution class, and after that we'll go through the code in the parking floor class and search manager class and look at the actual thread safe data structures that we are using. Now our solution class has got an array of parking floors, and it also has an instance of the search manager. It also has a list of vehicle types. For now the vehicle types are two-wheeler and four-wheeler. So let's go through the init method which actually initializes our solution. So what we are doing here is we are assigning a helper and then we are initializing the floors. And for each floor we need a list of parking spots to initialize it. We are getting this from the parking two-dimensional array. So for each floor we are getting the row and column, and we are calling this method get parking spots. And once all the floors are initialized, then we also initialize the search manager. That is all this init method is doing. So let's come and see this this method get parking spots. So this method converts a two-dimensional string array of spots into the actual parking spots. So we go through all the rows and columns. If the string is 2-1, then what we do is that particular spot becomes a new spot of vehicle type 2, and if the spot is 4-1, the string is 4-1, then it becomes a spot of vehicle type 4, else that parking spot becomes null. It remains null. That is all this method does. So remember, if it's an active spot, then it will be either be a spot of vehicle type 2 or a spot of vehicle type 4, else it will be null. That's all this method does. Now let's come to the park method. So in park method, first of all, we try to see that the vehicle type is valid, and then we also see that at least one of vehicle number and ticket ID is non-blank. Then what we try to do is we go through all the floors and we try to park our vehicle. If our parking is, if a suitable place is empty or suitable spot is empty on that floor, then our vehicle gets successfully parked there, and then what we do is we simply index that result and return that result. If we have gone through all the floors and our vehicle was not parked successfully, then what we do is we return 404. After that, there is the remove vehicle method. So here what we do is we try to search for the vehicle. We already have a search vehicle method in the solution class itself. If the search is null or we get a failure, then we return failure. Else we try to get the floor, row and column. And if it's a valid floor, then we simply call the remove vehicle method for that floor. We already saw this remove vehicle method in the ParkingFLoor class. So the same method we call. We will see the code for it later. Then there is the search vehicle method. So we simply call the search vehicle method from the SearchManager class. And finally, we have got a get free spots count method, where we simply check that if it's a valid floor, else we return 0. If it's a valid floor, then we simply call the get free spots count for that floor. We already saw those methods in the ParkingFLoor class. We'll see their code one by one later. Now the benefit of going through this top-down approach, like writing the code for solution class first and after that writing the code for the classes below, that is the ParkingLot class and SearchManager class, is that if you run out of time, then interviewer would have already understood your thought process and they can say that okay, you can skip this method.
Data structures
it is not very important
class
method. So that will be
the first one is
beneficial
free spots. So free spots is basically a map of vehicle type versus list of free spots of corresponding vehicle type. That's what it is. The second one is free spot size map. So basically in the free spots map is a vehicle type versus corresponding list map, and this free spot size actually keeps track of length of those lists. That is how many empty free spots for a particular vehicle type are there. That's what it tracks. And finally, we have the all spots array, which is basically all the spots on that floor. That is all the rows and columns, which will be either of vehicle type 2 or vehicle type 4 or will be null. So these are the data structures. Now the first question which will come to your mind is, why are we using a separate data structure free spots when our park and unpark functionality can be taken care of by the all spots two-dimensional array? So the answer to that is, if we have only the all spots two-dimensional array, then for the park method, in worst case, we have to go through all the rows and columns. So the worst case complexity of the park method will be order of n square or order of row into column. But when we are keeping this free spots list, then we have already a ready-made list of each vehicle type containing the free spots. So the worst case complexity becomes order of 1 and it's highly efficient. So the efficiency is the answer here. That's why we are using this free spots data structure. Again, you can ask, why are we using this complicated sounding data structure, complicated LinkedDequeue? If we have to use a list, we could have used a linked list or an array list. Yes, we could have used a linked list or an array list with a synchronized keyword or any reiterant lock in Java. But this concurrent LinkedDequeue is actually a lock-free linked list. So it is more efficient than a simple list with synchronized keyword or a lock. That's why you are using this data structure. Another question which will come to your mind is why we are keeping track of sizes of each list for a given vehicle type separately. Because this concurrent LinkedDequeue would already have the size method. But the size method in this concurrent LinkedDequeue is actually order of n. It goes through all the elements in the list. So first of all, it's inefficient. And the second thing is, in a multi-threaded environment, while the size element method is calculating size, elements can be added to or removed from the concurrent LinkedDequeue. So there are chances that in a concurrent environment or multi-threaded environment, our size will be inaccurate. That's why it's better to keep track of size in a separate hash map, integer versus atomic integer. And why we have used the atomic integer, not a simple integer? So answer to that is, atomic integer is a lock-free and thread-safe, efficient integer variable, you can say, in class in Java. So it's better to use as compared to the normal integer variable. Next, the all spots array, which is simply a list of all the spots, all the rows and columns in that floor. Next, let's come to ParkingFLoor. In the constructor, we are simply initializing both the hash maps, and then what we do is we insert all the list and corresponding size of the atomic integer, which represents size of those lists in the for each vehicle type. So we go through all the vehicle types in line 118 and in this line, and then what we do is we add, for each vehicle type we add a corresponding concurrent LinkedDequeue, and then for each vehicle type we add a corresponding atomic integer which will keep track of its size. The next thing what we do is we go through all the rows and columns here, and what we do is, if the spot is not null, then we add it to the corresponding list by using the spot.getVehicle type. Now free spots.get will not return null here, we know, because we have already added corresponding lists for each vehicle type. And again, we also increment the corresponding size variable for each vehicle type. So this is what this line does. Now we have already initialized and built our list of free spots and also updated their sizes in the free spot size map. Let's go through the park method. So in park method, first of all, what we do is we check whether there is a free spot left for that vehicle type in this floor. For this, we take the size variable and then we go through a while loop. Why do we go through a while loop? Because it's a multi-threaded environment and we want the read and then set operation to happen atomically. That's why we are trying it multiple times to happen. So we get the size old in this old variable, and if this old is less than equal to 0, then it simply means that no free spots are left for this vehicle type on this floor, and we return 404. However, if we are able to update the size properly, correctly, then what we can do is we update the can park to be true. Now size is already updated. Next step is we just get the free spot from the corresponding list in that vehicle type. We get the first free spot, we get it in order of 1, and what we do is we update the vehicle number and ticket ID and return success. If all our above steps have failed, then we simply return failure. The next is remove vehicle method. In the remove vehicle method, we first check whether row and column are valid. If not, we return error. Then we check whether the spot is already assigned to any vehicle, that is at least one of vehicle number and ticket ID should be non-blank. If both are blank, then we return error. Then after that, we update the ticket ID and vehicle number and add that free spot to the list of corresponding free spots based on the vehicle type. And similarly, next we update the size also for the corresponding vehicle type in the free spot size map and return 201. That's all this remove vehicle method does. It's add the free spot and update the size. That's all. Next is the free spots count. Now we have already keeping track of the free spots for each vehicle type in our free spot size map. So what we do is we simply fetch the size for that vehicle type and use its get atomic integer for that vehicle type and use the get method. It's order of 1 only, and already we check whether the vehicle type is valid or not and return 0 if it's invalid. Now all three methods, the park, remove and get free spots count, all three are order of 1 here. So we have an efficient ParkingFLoor class here. Next, let's go for the search manager class. Search manager class will be used to index the result, and second it will be used to search the vehicle whether it has been parked earlier. So we are using a ConcurrentHashMap cache variable to keep track of all the fields in the parking result. So why are we using a concurrent hash map and not a normal hash map? A normal hash map will give concurrent modification exception, or the data will get corrupted when we are using a multi-threaded environment. Now we can also use a normal hash map with a synchronized keyword or with a reiterant lock or any other lock in Java. But that will be inefficient because at a time only one thread can read or write from our map. In case of concurrent hash map, the default parallelism is 16 and the parallelism can be increased. So it is more efficient and error free to use in a multi-threaded environment. Read more about it on the internet. So the first method is index. So what it does is it basically takes all three fields in our parking result object and puts it in the map. So basically it gets the spot ID, vehicle number and ticket ID and puts it in the cache variable, puts the result in cache map. And why are we adding prefixes? So that we know that it's actually a spot ID or a vehicle ID or a ticket ID. That's the only point of adding the prefixes. The next method is search vehicle. So in case of search vehicle, what we do, we first search by spot ID, next we search by vehicle number and third by ticket ID. If nothing is found, we simply return error. Now we are expecting that at least not exactly one of spot ID, vehicle number or ticket ID will be non-blank. Let's suppose if spot ID and ticket ID both are non-blank, then first spot ID is checked, and if we do not get a vehicle for the spot ID, then it simply returns null. It will not check ticket ID, because it expects only one of these three to be non-blank. So this is all, and this method is also order of 1 because adding values to concurrent hash map is order of 1. So that is all about search manager class. Now let's copy the code from here and run it in our online editor. So let's copy from here and let's go paste it in our online editor. I wanted to show you one thing here. I have already submitted the test for execution. Initially, sometimes it may take some time. Now, this is the thing I wanted to show you. It has failed actually. There is a compilation error. The compilation error says that there is duplicate interface definition for Q001 parking lot interface. So what you need to do when you are pasting your code back to the local editor, you have to comment these lines back. The lines which we uncommented when we pasted our code in the local editor, this, else it will give duplicate definition error. Okay, so we now have commented it back now. Now let's run it again. It will be faster this time. So now it is already compiling the source code and all test cases have passed in like 6 seconds. So since it has passed all the test cases, let's submit it for further test execution. Now submitting your test case in an online editor and seeing that it has passed all the test cases in a multi-threaded environment, it will give you the confidence that you need for your interviews. Now, and if you have done this question and suppose in interview you get a slightly different question, for example, let's say implement a parking lot with 2 or 3 different parking strategies. Now you have implemented one parking strategy, so you know how implementing multiple parking strategies will look like. You can implement that. So this is one benefit. Again, now it has passed all the test cases, so we are
we are confident that our solution is correct. This is one of the ways of solving this question. There may be multiple ways of solving this question. There are better ways of solving this question. So if you do not agree with something, please jump into the comments and let me know. Also, I put the link to blog with code in the description, and I wish you the best of luck for your interview preparation and overall your professional career. If you want to discuss something with me, then I put my LinkedIn account link in the description. You can ping me on LinkedIn as well. Wish you the best of luck. Have a great day.